All right, good morning, everybody. Today we are going to try to find out what is the orbital altitude of a geosynchronous satellite. So what that means is this satellite, it orbits around the Earth and it always stays above the same spot of the Earth. So it has the same angular velocity as the Earth. Now, to start this problem, we have a few constants that we know already just by looking them up. So the mass of the Earth is 5.97 times 10 to the 24 kilograms. And the radius of the Earth is 6.39 times 10 to the 6th meters. And also the period it takes for the Earth to complete one cycle around is 24 hours, 1 day, which is equal to 8.64 times 10 to the 4th seconds. Now, we are going to try to find the force of gravity that's acting on this satellite. And to do that, we're going to use Newton's universal law of gravitation. So that is capital G, which is the universal gravitational constant, times m1 times m2 over r squared. So in this instance, r is the distance from the center of mass of the Earth to the center of mass of the satellite. So we also have this equal to this is equal to the force of gravity, which is equal to mass times centripetal acceleration, and this is equal to mass times the radius times angular velocity squared. So now we have to find angular velocity, and that would be delta theta over t, which is the period. So that's 2 pi over 8.64 times 10 to the 4th, and that equals 7.27 times 10 to the negative 5th radians per second. Okay, so now we can start plugging stuff in, but first we're going to take these two, and cancel some things out. So we have the gravitational constant. The gravitational constant also is equal to 6.67 times 10 to the negative 11th. So we have the gravitational constant times the mass of the satellite times the mass of the Earth all over this distance squared is equal to the mass of the satellite times the radius times angular velocity squared. So we can cancel out the mass of the satellite on both, and eventually we will get to the cubed root of, or r cubed equals the gravitational constant times the mass of the Earth over angular velocity squared. So looks like we're running out of room a little bit, but plug all those numbers in. So 6.67 times 10 to the minus 11 times 5.97 times 10 to the 24 all over Let's it over. We're going to cut this part out, I think. Oh, yeah. Where's my W? All over 7.27 times 10 to the minus 5 equals R3. So then R equals 4.22 times 10 to the 7. Now, the last thing we have to do is subtract the radius of the Earth from this number. So 4.22 times 10 to the 7th minus 6.38 times 10 to the 6th, and that equals 3.59 times 10 to the 7th meters, and that's our final answer. Well,
dude, I learned shit in there. Like, I didn't know the W meant angular velocity. On God.
how do I, oh wait.